My name is Mikhail. I work for Grid Dynamics. In Grid Dynamics, we do a lot of interesting things. The most exciting thing is it's our eCommerce search platform. And today we are talking about eCommerce search, and like shopping sites and so on. And can I ask you, how many of you work for eCommerce? Oh, only a few of us, right? Okay. So there is nothing about indexing real text like newspapers, articles, and so on. So only eCommerce search, really narrow niche. So we will look into the problem. So why makes eCommerce search so specific? Why it's so different to the classic search? And review several solutions which we designed especially for eCommerce search. So yesterday we had a great session about introducing to information retrieval, and you can tell me what the two conceptions which Lucene is based on. What are two powerful conceptions? So what Lucene is in the core? Can you? Anyone? Absolutely. So it's two main conceptions: Boolean retrieval and vector space. And the sad thing that these two conceptions don't work very well in eCommerce search. It's kind of challenge. So let's review the problems. How many of you search with query parser syntax on eCommerce site? How many of you? Almost no one, right? We're searching something like this by concatenating these short phrases, right? So, and Boolean retrieval is based on query syntax, right? So we cannot oblige our users to use query syntax. It's not possible. They will not search by this. If we look deep into the problem, we can find that the documents are rather different in eCommerce search than in classic search. In classic search, documents contains of many words, like it's also called like bag of words model, right? And these words come from a huge dictionary, and this dictionary has accuracy statistics per every word. And it's really important for vector space model, because if we have these statistics, we can evaluate one word match against another word match, you know, to rank our matched documents, right? And we have no such statistics in eCommerce search. In eCommerce search, our documents are rather shorter, right? And they're not so long, and they consist of fixed fields. Right, and the interesting thing is the field values. Field values is a B word, triple word, the multi-word field values. In this session, I call them compound word terms, to emphasize its nature. It's not a really good name, so that's what we really need. We need a good name for these values. Okay, and what the problem with these values? Because every word can occur in different value in a different field, right? And in this field, it has all accuracy statistics. So, and when users search for something, it gives you a word, right? You don't know whether it's important for this field or not. So you cannot use the vector space model quite efficient, as you could in classic search. It's all mostly the theoretical sentences, right? Let's look how it works in practice. If a shopper searches for pink sweater, why do you think the word pink means here? It's definitely color, right? And we expect that word pink will recognize it as a color. So there could not be any alternative recognition or interpreting, right? But in classic search, it will be captured as a one word from B word brand names. And it gives us some kind of problem. Here's a typical search result for pink sweater. Most of these are pink, right? Correct. But there are a couple of them which are black and white, and why they have been matched? Because they belongs to, they has been produced by a brand which has pink in its brand name and keyword brand name. So it's not really accurate, right? Here is another search result for pink sweaters. The same problem with these products, right? They has no any connection with pink color at all. They has pink in brand name. And here is our search result from our staging environment. So these all are mostly pink or with color which are synonyms to pink, right? And in brand facet, we have no any pink word, right? So we consider this search result as more precise. And here's the opposite side of problem. The problem is called polysemy, right? When same word can have different meanings in different contexts. So we think if user collocate these two words, pink and rose, they do not search for color, right? They search for this particular brand. There is a brand, pink rose, right? And these two words should not be recognized as colors, right? That we have an usual search engine. These two products has been matched because they have pink and rose colors in its product name. But you can mention also that most results are fairly correct. They belong to the necessary brand. So, and what we really need for e-commerce is just cut these minor matches, right? To show our users that we recognize, that we understand them right? That we got that they search for this brand. That's how we search for pink rose sweater, right? We recognize the brand correctly and provide the result only from this brand. The next problem, which we thought it's not really a problem, it's intention, our vision of the e-commerce search, that in e-commerce search, we need high precision rather than ranking. So we think if we have low precision retrieval, ranking does not really help us. Here is the search result for red dress. And you see there are a lot of mismatches. But it's mismatches from user perspective. But these man suits are fairly correct from classic search, from text retrieval, right? And you also can mention that most of results are correct, the addresses. So, and what we need for e-commerce, we need to have higher precision to cut these minor matches off. Precision is absolutely important for mobile search. So you need to retrieve fairly correct. You need to retrieve only what you really need because you have only a few inches to display result. And the core point which we are looping around in e-commerce search that we need to understand our user. We need to read their mind, you know? And if we do it right, if we make a really good guess about subject of interest, we can sell much better. We can sell more, we can improve our conversion. Beside of search itself, in e-commerce side, we have merchandising rules, right? And it's also a thing why we need to understand our users quite well. Because if we understand them right, if someone searches for some silver jeans and it's a brand name, we can redirect them to the brand landing page, you know, with a huge flash animation. Everybody loves it. And to do these redirects, the set of regex is not enough. You need to make high precise search, understand the user, and provide some merchandising action. Okay, it's all about problem itself. So let's wrap it up. Our documents are quite different to classic ones. We cannot oblige our user to use query parser. We have problem with polysemy, with different word meaning. And we think that precision is more important than comprehensive ranking. Let's review our solutions. The first is query parser. What we decide first is that we give up with tokenization. So we put these terms, these multi-word terms into index as is. So we think that this collocation information is really important. And we decide do not bother with praise queries. So it's too useless for this task. So we index multi-word terms, compound word terms without tokenization, right? The first point. Then when you need to search for some phrase, you need to generate all subphrases from this phrase, or also they call shingles, right? So you generate all these subphrases and search for them in parallel. You search for all these subphrases. You should not be scared. And also you need to search against all fields simultaneously. So this query is rather huge. And our top secret core matching criteria, so especially for eCommerce. So we think that we suppose that document matches the query if it has terms which are able to cover the search phrase, fully cover it without gap and without overlap. So for this search phrase, Black & Decker, toaster oven, we think that this document matches this phrase because it's able to cover, right? It has Black & Decker term and toaster oven term. And this is the mismatch case because this document has no term to cover word toaster, right? It's a gap, so we do not consider it as a match, but we accept this as a match in a low precise searching mode. So it's option. This third case is more really subtle. So in case of overlap in coverage, we also do not consider it as a match. So it's more complex question, but for sake of make it complete, right? To make my description complete. Side benefit of this query parser is multi-word synonyms. So in Lucene, multi-word synonyms don't work out of the box, right? With this query parser, which enumerates all subphrases, it works and quite smoothly. So in this case, we correct typo fee people to free people, so the correct brand name, and it could not be done with spell correction. So multi-word synonyms work smoothly out of the box. Recently, I found this academic white paper and was really surprised how it matches to our problems in eCommerce search. So if you work for eCommerce, check what the concept search is, you will be really surprised. That's quite relevant rather than classic information retrieval for text. Okay, that's over about query parsing. These parts is more really theoretic, and it was covered yesterday in introduction into information retrieval session. So just give me a sign, just wave your head, and I will scroll these slides faster. I will tell about what the precision is, what the recall is, and about the problem of tuning search engine, for problem of finding the balance between precision and recall. So we will scroll first 10 slides quite fast because we had a session about it yesterday. So it's expected, it's a relevant result, but in fact our search engine find something different, like which is just only overlap. There's an overlap between relevant and retrieved result, right? We can say that the overlap is true positive. Here is the two squares with false negative matches and false positive. It's okay, right? Do you follow? And we can say that precision is a ratio of retrieved document which should be found, right? Here is a recall, something like this. And the curious fact that we can have system with 100% recall quite easily. We just need to return all documents every time for any query. From formal perspective, it will be 100% recall system, but nobody really pay you for that system. And the sad fact that we cannot do something similar to get 100% precision system, right? Really sad. So what's the problem with tuning search engine? Here is our search engine. But by the way, how many of you tune search engine? How many of you work for finding the balance between precision and recall? Okay, some of us. Great. So I need to tell you about the problem. Why it's so difficult. So here's your search engine. And once a day, you find that there is some really important result, but you refuse to retrieve it, right? Something really valuable for a business, right? You need to tune some parameters and include it into the result, right? You include it, you improve recall, you include it into your result. But the problem is, at the same time, you make precision much worse, right? You start to return useless result, wrong result, spoil your results. And it's a problem of tuning search engine, like what you can tune in your search engine. I just show several parameters. So first of all, you can change query from conjunction to disjunction to get more result, to improve recall, but it harms precision. You can search for many fields, right? It also get you more result, increase your recall, harms your precision. The same about linguistic and stemming, right? You get more results, but it's not always great. And so the problem description is over. Let's go to solution. So the tuning problem is a general solution, general problem, which has no one-size-fits-all solution, right? We have no simple decision for this problem. And what we can do if we cannot find general solution? If we have no silver bullet, we can find something like suboptimal, which fits for this particular sphere. And our solution for this general problem of tuning search engines is that for e-commerce search, we need high precision rather than recall, right? And it's a core idea. What you need to do first? You need to introduce several fixed query parser configurations, right? And order them by descending precision, right? Put the most precise parser in first and put the highest recall parser into the end, right? And then solution is fairly obvious and straightforward, right? You can just loop through these configuration from most precise to most recall, right? And return the first search result, which is not empty. So that's all. That's all what we need for e-commerce search. And with this approach, we know that what we return for every particular search phrase has highest possible precision for this search, right? So we tune these trade-off dynamically for every search phrase. And you should tell me that there's a problem with this solution. It's not really acceptable in real life. You should say it to me. No? Everybody's happy? So it seems like, oh, hosts love it, I think. So it seems like really low performance solution, like, right? You search for the same thing many times. So you you harms your latency. Right? But it's not absolutely right, because if we dive into theory again, we find this magic formula, it's an estimation of searching complexity, right? And according to this formula, the searching complexity is linearly proportional to the length of search result, right? It means that if we have empty search result, we get it in a moment, right? And because of this, for first several stages, which return you nothing, you spend a really small time. It costs you almost nothing. That's great, but it depends. It's a trademark by Hoss, I think, or Lucene works. It's not true for several searching options, but it's true for all options which I told before. Okay. I can share some statistic from some e-commerce search system. It's these numbers for unique search phrases, but not for user searches. And it's really important because for user searches, we have much more better numbers. Numbers for user searches is really incredible. So for unique search phrases, we are able to handle half of them, 50% of them, by that compound term parser, by searching for shingles, right? And to handle 30%, we need to remove one of these words from search phrases. Right? We do not recognize one of these words, but it's still high precision. It's still high precision. And for 20%, we fall back to text match, to classic search by separate words. And staged search allows you get really high level of understanding of your user, because you have really high precision. If you have high precision, you understand your user quite well. And that increases your conversion and profitability. Okay, last part, last solution. We call it match spotting, but name is not really well, so contributor name. Tell us how to call it. At previous part, I proposed to introduce several stages, right, and introduce several fixed configuration, where it comes from, how many stages you need to have, which settings you need to put into every stage. So the answer is you need to have match spotting, right, to process your query log by match spotting and aggregate all matches statistics, right, to get model of your user, to understand how user searches. That's why you need it. Let's look into solution itself. Everybody is familiar with facets, right? And the interesting thing that looking into facet counts, you can understand what your user is searching for. For example, if you look into these facets, right, we can conclude that someone searched for this brand, right, and possibly for this product type, for sweater, right, and it will be a very good guess. The second component of match spotting is this explain information. Some of us are able to read these horrible verbose dumps, right? It's really complicated piece of information, but really valuable to understand your search. And particularly from this dump, we can conclude that this document has been matched because it has 3 people in the brand field, right? And sweater in product type. That's great. And what we really need for e-commerce search to understand our users, we need to merge these two conceptions. We need to merge explain and facet. We need to go through all search results, get explain information, and aggregate them as we do for facets, right? And it will be really valuable information for your business. For example, if you search for silver jeans and found 190 products, right, from looking into match spotting statistics, we can conclude that this search phrase mostly means a brand, right? We can make really good guess that customers search for this particular brand. And only minor part of products belongs to other brands and can be recognized as searching for this color, for silver color for jeans, right? You should not show it to users, right? You need to put it in search tab. You need to put it into a merchandising rule engine, right? And you can redirect users, particularly to this brand landing page with a huge animation, flashes, right? Or you can drop them to the jeans category and pre-select this brand and provide link for reviewing those minor part of result, something like this. And last word about match spotting, that you cannot implement it as it's shown there by using explain, because explain itself is really slow algorithm, really inefficient. So we did it by massaging around the scorers, right? And our algorithm is tightly bound, tightly related with scorers' behavior. And internal scorers' behavior is the subject for changing. For changes. So there's no simple, fast solution still for match spotting. That's all from me for today. So we've looked into the problem itself, why e-commerce search so different from classic information retrieval. We've looked into query parser, into specific type of query, which we use for searching in shopping sites. And we reviewed the possible approach for solving the problem of balance between precision and recall. And we've looked into how we can get the model of searching behavior of our users. That's all for me. Thank you for listening. I'm looking for your questions. And here's a shortcut, which you can access slides by. Okay, do you have a question? Can you pass? Okay, can you pass the mic? Typos. First of all, the question about typos. The question about typos. Do we handle typos, or how do we handle typos? We absolutely do need handle typos. So we have several stages at the staged search with enabled spell correction. So it's not a big deal. What works great in that query parser is misplaced space typos. So if someone forget to put space between Calvin and Klein, it will handle it quite well, because we can easily, if we have dictionary, we can easily find the Calvin Klein brand by the concatenated words without space. So space correction works really great, and spelling works also quite well. So we apply spelling correction somewhere when we get all shingles, somewhere here, right? You can look up every this phrase in the dictionary and correct spelling, so it works. We provide this service. No problem. That's all. Thank you. So I'm open for questions. Thank you very much for attending.